Well, so thank you for attending today's program, Introduction to NFPA 13 Fire Sprinkler Systems, presented to us by Telgen and Luis Escobar.
Thank you, Jeff. Welcome everybody. This will be a presentation, and we're going to talk about introduction to NFPA specifically for fire sprinkler systems. This will be a basic presentation so we can all know the different systems, the differences between the sprinklers by themselves, but we'll get to that. I'm with Telgen Engineering and Consulting. We do fire sprinklers for many companies. We have a couple clients that are not too picky. Sometimes they are, sometimes they're not. But most of our work consists in fire sprinkler designing, as well as another activities, for example, fire pumps and fire alarm systems for the same projects we're working on, right? So I'm gonna go ahead and start the presentation. This is me. I'm a fire suppression designer, and I currently have a NICE level 2 certification. Sorry, as I was telling you before, we're going to talk about the NFPA 13. As you may know, there are a lot of different versions of this standard. The most current one is the 2025th edition. But some of the slides you're gonna see here are related to probably the 2019 version. Just the reference to the code, it's not that something changed, it's just a reference. All right. These are some topics we're gonna see for different stages of this training. And we're gonna start with a little bit of history of NFPA 13. As you may know, the fire industry started long ago. This is not a new technology IA system, for example, that started 2 years ago. The origins of fire extinguishment go back to the 1890s, which was the first intention to create an NFPA or a fire extinguishment system standard. And at that time, rules and regulations were taken into account. So the first committee, we can say the first committee was created at that time, right? But that was obviously long ago. We have implemented technology on valves and piping on devices, not technology as in computers, for example, but technology on water efficiency, on pressure loss efficiency, and all that, right? So, as I was saying, the latest edition of NFPA 13, it's the 2025th edition. If I'm not wrong, California has adopted the 2022nd edition for most of their jurisdictions, and they're probably gonna bump up to the 2025th edition very soon. And most of the times, every 3 years, a new code is released with updates, for example. Sometimes they're big changes, sometimes they're not, sometimes they change the way to show things, but between 2019, for example, and 2025, there have been a couple major changes on new design criteria. And in the new edition, the NFPA committee is working on, it's the 2028 edition, which is currently on their review. Not only the NFPA 13 by itself, it's the standard to install or how do we need to install sprinklers. We also have NFPA 13D, 13R. These two are more oriented to residential or dwelling units for where people lives, right? Because we had a standard to protect the occupancies on, for example, manufacturing plants, aircraft hangars, or hospitals and all that. But we didn't have one standard to protect homes, which are a high risk for people when there's a fire, right? We have noticed that 50% of total life loss was in homes. So there was a need to create a standard to install sprinklers, to design fire suppression systems for homes in order to save lives. That was the purpose of these two. And as I was saying, NFPA 13, it's more for commercial or storage or occupancies not related to residential applications. 13D, it's for dwelling units, and 13R, it's for residential. All right, let's go and start the code requirements for the NFPA 13. So how do we know that we need a fire sprinkler system? And what are the entities that regulate that system? How they know the system works? So they're typically mandated by codes, laws, ordinances, insurance mandate, owner election, not by installation standards like a maintenance manual or installation guide. That's not a document we need to go off of when it comes to design a fire sprinkler system. I'm just going to give you a quick example on this slide between owner election and codes, because sometimes when we go to the code, which is going to be NFPA 13 in this case, we have certain schema protection, which can be, I don't know, certain amount of water or a certain sprinkler that we need or a certain design criteria, let's say that. But the owner sometimes has their own team. Their own team has developed a different standard. So we mixed those two. The owner election design criteria and the code criteria. But the owner election criteria can never be less than what the code mandates. So it's not something mandatory, but some clients might need a combination of code versus their own design criteria. And obviously, we need to comply with law, ordinances, and insurance companies. Sorry. Codes and standards. What's the main difference? Two words: when and how. Codes mandate when something must be done. And we're going to focus on this one, standards, as NFPA 13 is a standard for the sprinkler installation. NFPA 13 mandate how to do it, how to install the fire sprinklers, how to install the piping, if we need to slope it, if we need certain type of pipe for each application, or if it has to be underground, or it has to be exposed to the exterior, all that. So we're gonna be more digging into this. How do we know what type of sprinkler we need? We previously went over a slide saying, how do we know if we need a fire sprinkler system? But now, what type of sprinkler system we need? That's going to be defined by the combination of all these bullet points. Size of the building. As we know, some buildings that are too high or the ceiling is too high, it's a problem for the fire sprinkler design. And I know we are paying sometimes, sometimes not. We try not to, but it's because of the standard, the height of the building, how it's constructed, what type of construction, the occupancy, if there's something stored, what's the danger of storing something very that releases more heat than other one. So all these characteristics define what the sprinkler system needs to be. Most important, I would say, it's the height of the building, what are we storing, and the occupancy type. For example, it's not fire sprinkler related directly, but for example, the occupancy type, construction type. It's not the same to have a type 2B building to have a type 4B building. And that's gonna be more related to the underground system because the California Fire Code states what is the total demand of water that we need for each construction type. A 2B type building will have a different water demand than a type 4 building. And it depends on the square footage and all that, but as an example, not related to fire sprinkler board, but it supplies the fire sprinkler system, the underground piping size and demand will be defined by the construction type. So it's not only fire sprinklers, it has to do with a couple more items that are directly related to each other. NFPA 13, this standard shall provide the minimum requirements for the design and installation of automatic fire sprinkler system and exposure protection sprinklers. As we saw in the previous slide, how? The keyword is how. How do we need to do this? How do we install? How do we locate? How do we slope the pipe, for example? And very important, this standard is written with the assumption that the sprinkler system shall be designed to protect against a single fire originating within the building. NFPA 13 and any fire code will only take into account one fire at a time. If two fires occurred in totally different areas in the same building, the sprinkler system most likely is not going to work because that's going to be provoked. Somebody set the fire, somebody initiated the fire in two different places, and that's not something that NFPA covers because a fire, it's basically an accident that something happened. Probabilities are very low. So keyword, single fire originating within the building. Fire sprinkler systems are not designed to extinguish two different fires located in two different areas of the building. The purpose of the standard shall be to provide reasonable degree of protection for life and property from fire. Obviously, we're more focused on life for obvious reasons, but we need to take into account that the property is also important. We don't want a building that is totally consumed by fire if we can stop the fire in the 10% of the building, for example. Right? All right. Fire control, limiting the size of a fire by distribution of water so as to increase the heat release rate in pre-wet adjacent combustibles while controlling ceiling gas temperatures to avoid structural damage. What we do with fire sprinklers is to release water of those sprinklers, obviously. And besides extinguish the fire by itself, the one that is already happening, we spread water throughout that area so the rest of the material can be wet and the fire doesn't spread too quickly. It's one of the purposes. Fire suppression, sharply reducing the heat release rate of a fire and preventing its regrowth by means of direct and sufficient application of water through the fire plume to the burning fuel surface. Very similar, but fire suppression means extinguishment, basically. Keyword, extinguishment. Do sprinklers extinguish a fire? In some cases, they can. As we previously saw, not all cases apply, right? If there are two fires, it's impossible for the system sprinkler to work properly. Here's an example. Consider a single fire. It could be probably, I don't know, a couple of paper sheets burning or a wood construction chair that it's on fire. Obviously, it's considered a low, medium heat release. So a well-designed fire sprinkler system won't have any problem by suppressing that fire. But what if we have a rack storage of combustible material, which can be plastic? We all know plastic is very, very flammable, and they're stored in cartoon boxes, for example. Obviously, there are schemes of protection for all these applications, but what I mean with these two slides between this one and this one is that the fire sprinkler system for the first one will be totally different from this one, because for starters, this will need more water for obvious reasons. There are a lot of carton boxes set on fire. The heat release is gonna be way more high. The sprinklers by themselves are gonna be different model, even bigger. The artifice is gonna be larger, so the water can be released more efficiently. The pipes, that's the problem when we have a project with big diameters. We all know everybody suffers when it gets to coordination, right? So these two systems are gonna be totally different, talking about pipe sizes, sprinklers, and probably the orientation of the sprinkler head. Fire sprinkler systems. So what is a fire sprinkler system by itself? An arrangement of piping, control valves, and automatic sprinklers that extend throughout a building, and upon activating by heat, water is automatically discharged to control or suppress a fire. Keyword: activation by heat. We all know the activation method for fire sprinklers is obviously heat. That's why it's important to take into account temperature ratings for fire sprinklers, because if we have a manufacturing process that involves I don't know, high release of heat, maybe a fire sprinkler can be activated by mistake. But let's go back to the definition. So this is a typical fire sprinkler underground arrangement. Could be a water storage tank, fire pump, underground piping, then control valves as we saw here, riser, which most of the times we have the valves to control the system to close and test and for maintenance purposes. Piping, obviously, we have feed mains, cross mains, and branch lines, and this automatic sprinklers by themselves. So all this is considered a fire sprinkler system that it's gonna prevent fires on building constructions. We have 4 types of sprinkler systems: wet, dry, pre-action, and deluge. This type of system is gonna be probably 90% of the systems that we design as in the fire industry. Well, probably not 90, 80, let's say 80. But it's a large amount of projects because it's indoor, right? By systems. We're gonna go over those very quickly. Wet sprinkler systems. The way to differentiate this one from the other ones is that there's always gonna be water inside all pipes. Okay, these pipes you see here, here, and all over the place contain water inside them. That's why it's called wet. All systems, when there's a fire, release water. Let me get that clear. But the difference for the wet system is we always have water on the pipes, in the pipes, I'm sorry. Here is least complex and most common type of systems. As I was saying, it's probably 80% of the systems that we designed. And most of them for indoor occupancies. Connected to water supply so that the water discharges immediately from the sprinkler when they open. Method of activation for a fire. We saw that it's the fire sprinkler. When a fire sprinkler is open, the water starts, the sprinkler starts releasing water. The second type of fire sprinkler system is a dry pipe sprinkler system. In this case, I'm gonna go to the image. We see the blue part of the system. This part contains water, always. But the yellow pipe, it's all dry. That's why we call it dry. There's no water inside it. It's a closed system. Most of the times we fill these pipes with air or nitrogen. It could be any of them or any. But when there's a fire, we know the sprinkler opens, and then all this air goes out of the system, and when the water reaches the open sprinkler, the water starts falling down, right? So most important characteristic on this system is there's air on the pipes upstream, and when there's a fire, a sprinkler opens. Once all the air is released, then the water starts releasing. Okay. Applications: unheated warehouses and plants, attics, coolers, covered docks, parking garages, etc. It could be also a good option for outdoor systems. For example, when there's freezing conditions, we can use these systems. The disadvantage of these systems are that they are most likely exposed to corrosion, and the maintenance, it's most obviously it's costing. That's why these are not, they're common, but not that common as the wet systems. Okay. Pre-action systems. I've personally designed a couple of these for special applications. They're being used nowadays for applications like those data centers for the companies that they're big tech companies, and they have servers and they have all those expensive equipments that they don't want a false water release for their equipment, that because it's very expensive. So as I was saying, very expensive equipment, museums, libraries, computer rooms, clean rooms, freezers, data centers, electronic equipment rooms. The intention of this system is to control the way the water is released. Pre-action gives us an idea of something has to happen before the water is being released. What happens here is we have two conditions so the water can be released. One of them is the sprinkler by itself. That's one condition. If the sprinkler is open for this system, it not necessarily means that the water will be released, because we need to meet the second condition, which is going to be, it could be a smoke detector activation, a heat detector, or any other mean of activation for fire sprinklers. But long story short, for this system, we need to have two conditions so the water can be released, and we don't have an issue releasing water where we don't want water, right? It could be the last resource for very expensive occupancies. Sprinkler types based on characteristics: thermal sensitivity, temperature rating, orifice size, installation orientation, water distribution characteristics, special service conditions. All these are gonna be helpful so we can design our fire sprinkler system. But most importantly, there's not one most important than other one, but I would say all of them are very important. We need to take them all into account when it comes to designing a fire sprinkler system. The first one will be the thermal sensitivity. Thermal sensitivity. standard response versus fast response. What can you see here between these two sprinklers? The diameter of the bulb, it's thicker here and thinner here. Which one do you think it's standard response? Obviously, it's gonna be this one, and the fast response is gonna be this one because the heat takes less time to break this glass or penetrate or the thermal conductivity to heat the fluid that it's inside and make it explode. That's the way we activate these sprinklers. Fast response and standard response. Sorry, let me go to the next one. Here you go. All right. There's another type of sprinkler that has another type of activation. Fusible element. This part that you see here on the sprinkler, it's called the fusible element, and it has the same function or the same task as the bulb has. When this one breaks, the water is being released, and when this one moves, the water is being released. This one takes the same principle than the previous one. When the heat starts expanding this metal, it moves and lets the water start flowing through them. Okay. What will be the main difference between bulb sprinklers and fusible element sprinklers? These are a little bit less expensive, not that much. I would say 10% probably. And the response for a fire, it's a little bit better on these. It has been tested, and it's well known that the bulb sprinklers have a little bit better response to the fire than the fusible elements. It doesn't say that these don't work at all. I mean, it's not what I meant. I was just saying that the bulb sprinklers are a little bit better on thermal sensitivity than these ones, but both work perfectly. Temperature rating, you see here in this one that it's red. The fluid inside the bulb is red. And it's going to take us to the temperature that they rated. Orange or red means 135, 170 degrees to break the bulb. What happens is the heat penetrates the bulb, starts heating the fluid, which is a fluid that expands, and when it expands, breaks the bulb, and the water starts flowing. So different colors means different temperatures of activation for different applications. It's not going to be the same to have a sprinkler on a ceiling for a manufacturing plant or a metal extruding plant than a break room, for example. Obviously, the break room will have air conditioning. It's going to be, I don't know, 75 degrees all times when it's air conditioning control. And when there's a fire, the temperature starts going up until we hit this value. Then the bulb breaks and the water starts extinguish the fire. And the same for all these. Personally, I've never used purple or black. These are applications that I've never worked on, but I've used the blue because I was designing a plant that they had a process that they were releasing a lot of heat, and they needed this temperature. Orifice size, this will be the orifice size of water discharge. The most common one a couple of years ago, or a lot of years ago, was the 1/2 inch, but now we have even orifices less than this for residential occupancies. For offices, for example, is 1/2 inch. For storage is 1 inch or 3/4. Spray sprinklers. Now the standard is 100% of discharge is downwards. There's always a confusion. Well, not always, sometimes, right? When we speak about pendant and upright sprinklers, because the orientation of no, the pendant is oriented downwards and the upright it's oriented upwards, right? And at the very beginning, when I started in the industry, I used to think that the upright sprinklers released water to the ceiling, but I mean, obviously they don't, right? But it can be confusing sometimes. The type of sprinklers would be sanded coverage. These sprinklers are designed so they can spread water more horizontally than the standard ones. Storage sprinklers, probably sprinklers that can be installed between the racks. Special application sprinklers, we're gonna go over that in a couple of slides. Standard spray sprinklers with special feature, for example, if they are corrosion resistance. Maybe if the application is to protect a canopy outdoors with a dry system, we saw that those systems tend to be corrosive, to be in corrosive environments. So it could be a corrosive resistance sprinkler with a polyethylene cover, right? And residential. Okay, timeline for sprinklers. I'm not gonna go over this very deeply. We were speaking that the fire industry started when we had the need to extinguish fires, and we have improved since then. Here's what I was talking about the different sprinkler orientations. Upright will be this one. Imagine the piping it's running horizontally, and then we install the upright head here. So it's gonna be oriented upwards, which I used to think the water was released to protect the actual ceiling, but it hits the plate and the water starts falling down with an umbrella pattern. The other one we have is the pendant sprinkler, installed at the bottom of exposed piping or on a pipe drop below finished ceilings. If we have a storage building, for example, the pendant sprinklers could be up high in the ceiling at 22, 25, 30 feet high, but sometimes they can be installed in the offices area, which are 10 feet high most of the times. So these sprinklers, the pendant ones, the water is released downwards and they hit the plate, and the water is released with a pattern, with an umbrella pattern as well. You can see the curve in the plate. That's what makes or provokes the umbrella pattern. Sidewall sprinklers, these are not very common for most of the applications, but they're very used probably on applications where we need more, the water extends more in the horizontal plane. Coverage for each sprinkler, light hazard, or any extra high pile in ESFR. The first three are the most common ones: high pile storage and ESFR. We're talking about more for storage applications. Light hazard and ordinary, they have different spacing between sprinklers. The area that one single sprinkler can protect could be 196 square feet or 120. It depends on the construction by itself. Sometimes there's sloped ceilings. Sometimes that's what I was saying, that we are paying because we're always asking, and please send me the updated structural plan, because we need to confirm that the beams, the depth of the beams, the space between them, so we can space our sprinkler heads Sometimes if the beams are too deep, we need to go lower in this number, and that's a critical case. So the system works when there's a fire, in case there's a fire. Hopefully not, but if there is a fire, we need to make sure the system is going to work. Extended coverage sprinklers, they cover more area, but they demand more water because they need to cover or protect more area, and we cannot have a area where there won't be water released for that area. Control mode density area for storage sprinklers, control mode specific application, and early sufficient fast response. These two are pretty similar. I would say these two are the most common for retail stores or for specific use. For example, tire storage or roll paper storage. Remember, we're talking about storage in this slide. And the most common, and I would say easiest way to protect a storage system would be with the ESFR sprinklers, designated and tested specifically for storage hazards. What can we say about these three sprinklers? We saw that there are different orientations for them. Example, we had pendant, we had upright, and also we had sidewalls. These three are uprights, upright heads, because they're oriented upwards. The activation method will be for these two on the edges, would be the fusible element, and for this one will be a bowl. When this one breaks, the water starts releasing. And there are a lot of finishes for them. They can be corrosive resistance, they can be brass, chrome, and I mean there's a very vast category to choose them. Residential sprinklers, NFPA 13 by itself doesn't provide guidance to residential. That's why we go to 13R or 13D. But these sprinklers are very small. They don't release too much water. And one of the main features of these residential systems is that we can use, it depends on the jurisdiction, but sometimes we can use not metallic piping. This is a dry system. For example, if we have a wet system on the ceiling, but we have a cooler, we can have a drop, a piping drop, and install that sprinkler, which has a dry barrel length here. So the water is not gonna froze. And we'll make sure the protection will be taken care of in that cooler, just as an example. And corrosion resistant sprinklers, as we mentioned, for outdoor areas or environments that are corrosive. Metal building sprinklers and institutional, which are for when there's a mental health occupancy and people can use the sprinkler to damage themselves or something similar. So there are vast quantity of sprinklers for that. Storage occupancies, the most critical design for our industry, I would say. What is a hazard? What is the building constructed of? And what type of system is required? What, how, and how high? What are we going to store? Plastic, concrete, dust, wood. How? Racks, high pile, in shelves. How high? How high is the storage? If it's gonna be a 5-foot pile or a 25-foot rack, the scheme of protection will be totally different between those two examples that I just gave you. Occupancies of classification for, in NFPA 13, light hazard, ordinary hazard, extra hazard, and special hazard applications. We'll go over those. Light hazard occupancies. The difference between these here, it's the amount of heat released by the combustible on the occupancy. For example, light hazard. This gives us an idea that the fire sprinkler system won't be too complex to extinguish the fire. The smaller pipes are needed, a small sprinkler head, not storage. So, I'm sorry, a church, an occupancy that has limited combustible materials. It can be a library, which even though we have books and occupancy that can be combustible, the heat released by those combustibles is not that high to consider a life-threatening issue compared to the heat release in another applications. Don't get me wrong, these two are important as well, but the heat released by these combustibles is not the same as, let's say, a mechanical shop, where we have oils, we have solvents, where we have all those materials that take a lot to consume, and the heat release for those materials is way higher than a paper sheet. Ordinary hazard group 1, parking lots and restaurants, for example. A little bit more heat release and light hazard, but not too high. Ordinary hazard group 2. This is the design criteria we use most likely for mercantile occupancies, mechanical shops, and another application where there's medium heat release. Extra hazard, here's the applications where we have combustibles that are dangerous, not dangerous for the life itself, but if they set on fire, it's gonna be hard to extinguish, and the heat release will be way higher than the other ones, the previous ones we just saw. Extra hazard, aircraft hangars, metal extruding plants. We would say metal is not that dangerous, but it doesn't have to do with the material itself. It has to do with the heat release by those, because metal melts when it's 2000 degrees or so, or 1000 degrees. Extra hazard group 2, paint cabins. This has to do more with plastic combustibles, because paint will be basically plastic. And pre-assemble home facilities. We were talking about the combustible and the heat release, the heat that they release, and they can be categorized in class 1 through 4, carton unexpanded group A, carton unexpanded group A, uncarton unexpanded group A, uncarton expanded group A. The group, it has to do with the type of plastic that is. There's 3 types of plastics, A, B, and C, and it depends. I mean, of group of plastics for NFPA, but it has to do with if it's PVC or if it's polyethylene or if it's PET, or it depends on what type of plastic is. We have a couple examples here. Class 1, it goes from the lower group to the higher or most dangerous group. 1 through 4, if you see here, progressively they increase the heat release of each one of them. Plastics, combustible liquids, flammable liquids, and aerosols. These can be also explosive, so they're pretty dangerous. Okay, so now we can say we know a little bit more about all these topics. We know a little bit more about commodity classifications and what type of sprinkler we might need. Or for example, if we're building a hospital, we're gonna need a wet system, for example. It doesn't make sense to have a pre-action system for a break room. So that's basically the intention of this training or of this course, to provide a little bit more guidance when it comes to choose a fire sprinkler system. All right, guys. Hopefully, it wasn't too boring, but we get to the final stage. Do you have any questions for me? I think I have the chat group here. Oh, well, not sure if somebody has any questions.
Yeah, let's see. We have one right now. Can one system provide, looks like another one's coming in, provide an
Yeah.
NFPA 13 on the first floor of a building, let's say parking garage under podium type A, and NFPA 13R above floors with residential units?
Yes, that's totally fine. If we have a parking on the ground level, for example, that's gonna be protected with NFPA 13. Most likely we're with ordinary hazard group 1. And the rest of the building, which is gonna be the residential units, we need to use NFPA 13R to design those systems. It depends on the on the hazard by itself. So the answer is yes. We can use both codes to design.
Okay, next question. Is there a quality residential sprinkler with a concealed head?
Let me see that one. Is there a quality residential sprinkler with a concealed head? You mean like if it has a good quality or some finish, for example, corrosive resistance? Not sure what the answer was. I mean the question was, sorry. I mean, as I was saying, the residential sprinklers, most of them have both activation method, and as long as they are UL tested or approved or FM, they're good to go. But it's important so they're listed under UL or FM. Visually
And add
looks
on to that, visually looks to blend in with the ceiling.
Well, I would say it depends on the if it's an existing sprinkler that it's already installed. Visually it has to be not painted, externally painted. For example, if we have the ceiling painted white and the sprinkler originally was chrome, we can't paint it with white paint, right? We need to make sure of that.
And
Yep.
we have another. Do you get annoyed when movies depict sprinklers discharging all at once when a fire alarm is pulled?
Yes, I was remember one movie. I think it was Final Destination. I don't even remember. I think it's Final Destination, where when a guy had a wood stick and it was on fire, and he put the fire close to the sprinkler, and suddenly all the buildings started to release water, and I was like, oh god, no, that's not the way it works at all. It activates one by one. So yeah, we are annoyed of that.
And boy, the comments are just really coming in. So the next one, is there a specific height of a ceiling skylight? Well, in residential, where an additional sprinkler head is required beyond what is already covered in horizontal spread of the typical ceiling. If so, where would I find this in the fire code?
When there's a ceiling pocket, I think you're talking about a ceiling pocket. We will need we most of the times need an additional fire sprinkler there, because the whole purpose of the sprinkler is to have an activation by heat. And if we have a space that is above the average of the other sprinklers, the heat is going to go there, and the rest of the sprinklers are not going to activate never. So I don't remember the exact section of the code, but let me find it for you, and we can email that to you without any issue. Thank you for asking.
All right, the next one, is there a code requirement for mounting height of fire pole stations, and where are they required?
Well, I've seen them most likely 4 to 5 feet. Most of the times 5 feet. And they required for well, most of the times when there's an exit door or egress door, so that people can activate it when they're evacuating.
And I would think that it would fall within the ADA requirements for mounting, wouldn't it?
ADA requirements. Oh, I'm not very familiar with it, to be honest.
Oh,
The
there's somebody
ADA
just asked that
requirements.
question.
Yes, exactly. But yeah, for sure there is a code that states that height. So 45 feet. I mean 4 feet. Yes, exactly. I think it's between 4 and 5. Not sure if it depends on the jurisdiction, but I've seen in between 4 and 5 feet height off of the finished floor, which is not part of the sprinkler system itself, but it's that the pull stations are meant to activate the alarm system, not the sprinkler itself, because sometimes we think by pulling the that um that item we're gonna activate the sprinkler system, but no, it's more to the fire alarm system. What requirements exist for purging wet systems? Uh, that's that's a problem. I mean, we usually do maintenance tests on the riser, but we don't drain the total amount of water. I would say we take a measure when there's a system for example offices where we have a piping up in the ceiling and then we go down with a drop. Sediments will gonna accumulate on the sprinkler, and the way to prevent that is to do a goose. We call it gooseneck. Let's imagine we have a horizontal pipe. We go up a little bit, elbow, then down. That way, the sediments of the total sprinkler system are gonna accumulate on the entrance of the sprinkler, and that way it's not gonna be obstructed when there's a fire. But it's not very common that somebody drains all the water on the ceiling system. I would say only we do maintenance tests to see that the pressure will be enough to operate those sprinkler heads. All right.
Yeah, I think we're good.
Thank you very much for your kind words, everybody.